Okay, this is the solution to Learning Assessment 10.2. Problem says find I1, I2, and V0, and we're going to use our problem solving strategy entitled Magnetically Coupled Circuits, which says first assign mesh currents. Well, we're already assigned mesh currents I1 and I2 in this problem, so step 1's already satisfied. Step 2 says write mesh equations by applying KVL. If a defined current enters the dotted terminal on one coil, it produces a voltage in the other coil that is positive at the dotted terminal, and vice versa. So let's start at the left mesh. Let's go around clockwise. So if we start, we'll have 24 to angle of 0. Okay, now we'll have two voltage terms for the inductor, one due to current I1 and another due to current I2. One of those, one due to current I1, is J4I1. Okay, so we'll have a term J4I1. Now, the current enters the dot. Over here, it's going to produce a voltage that's plus at this dot. So we'll have another voltage term. That'll be J1 times I2. So we'll have a term that's J1 I2. Then as we come on around, we'll have 4I1 equal to 0. The J4 I1 term we'd have even if we didn't have coupled inductors, so our equation becomes 4 plus J4 times I1 plus J1 times I2 equal to minus 24. Now let's do the second mesh. So if we start, we'll have 2I2, drop here, we'll have minus J4I2. Okay, now as we come around to our coil, we'll have one voltage here that's J8I2, and that's due to current I2 flowing. And now we also have a voltage term due to current flowing over here. And we notice I1 enters the dot, so it's going to produce a voltage plus to minus J1 times I1, and notice it's the same polarity as the J8I2 term, so it becomes plus J1 I1 equal to 0. So this equation becomes J1 I1 plus 2 plus J4 I2 equal to 0. So there's our second equation. And if we solve, we'll get I1 equal 4.29 at an angle of 137.2, and I2 equal 0.96 at an angle of minus 16.24. And if we look at our circuit diagram, V0 is minus J4 times I2, and that's 3.84 at an angle of minus 106.24 degrees.